Turn around like the prodigal son and come home. Ooh, yeah. Make a U-turn before the crossroads, the Lord's calling is home. Ooh, yeah. Turn around like the prodigal son and come home. Ooh, yeah. Make a U-turn before the crossroads, the Lord's calling is home.
Tell somebody, street saints up in the place of a rockin' this party. It's the heavenly profound ultrasound, coming and it's coming fast. Full blast, coming back like the future from the past. Believing you don't want this cop to pass you by. Lift your eyes to the sky before you look down. While MCs remain underground, the Ranza will be teaching you how to ski on clouds. I will rock the crowd, no diggity dodge. You can't be chilling the way we spitting, we be making you shy. Ooh yeah, yeah. Hambo kaneta, ndlebe loka ibula-bula, itapula ivumela, you can bet. Nah, it ain't about what they say, him or what she says. Forget about those evangelistical cliches. It's all about what he says. First epistle of street says, calling all sinners to return to Jesus.
Turn around like the prodigal son and come home.
Ooh yeah.
Make a U-turn before the crossroads, the Lord's calling is home.
Ooh yeah.
Turn around like the prodigal son and come home.
Ooh yeah.
Make a U-turn before the crossroads, the Lord's calling is home.
Good afternoon, good morning, good evening, depending on your time zone on this planet, this flat planet, or this oval or spherical or whatever shape you prescribe to. Yeah, so so today we're gonna bring on the old argument of the shape of the planet Earth. So there is a new movement that started probably, well, I picked it up around the 21st century, around this decade, where people have come out and tried to argue the whole thing of the Earth being flat, and obviously then the origin of this theory, the oldest mention of the Earth being flat came from medieval Europeans. We're not rejecting the theory because it's medieval European, but it was conceived by people that did not understand, had not yet developed the calendar, did not understand the cycles of the universe. They thought that if the Earth was, or you could fall off the edge of the planet or something, if it's round or something like that. So that's their level of thinking. So I decided, so there was basically a debate on Twitter about it. And as you know, when people type up stuff on social media, it's mostly spam, S-P-A-M. Why I say that is people talk past each other, people can ignore questions and things like that. That's why most of them do not accept any challenge to come live. So in the thread where the people were going back and forth about the why the planet is flat, they just kept on typing and typing for days. And so I invited them to bring it to space, to bring it live, and their response was, it doesn't need a debate. And the question is, if it doesn't need a debate, why do you talk about it for more than 24 hours? People keep going back and forth. That's because when people are typing up stuff, they can just ignore things and just go back and forth. But you can't do that live. When you come live, you can be asked a question, and you can't run away from the question. You either answer the question or you get exposed. So So yeah, so that's why I decided to bring it up here. Didn't expect any uh, large response, of course, from the flat earthers, because obviously they are afraid to bring it on, to actually face up to the questions on a live basis. And one of the people said, I just want to read his response. He was actually invited by one dude. The guy invited him to come and debate, and the guy said, "Oh, is that a space?" So someone invited him, said, "Yeah, here's a challenge. Should be fun." And then he said, "Is that a space?" Yep. And his response was, "This thing doesn't need a space. They must just prove their spinning globe theory." So I responded, and so the discussion is on the flat Earth theory. That's what needs to be proved. And he responded by saying, "Why does it need a discussion when everyone observes it every day, though? I mean, how does everybody observe a flat Earth on a daily basis? So you can see that most of the rhetoric is basically, it borders around like a cult, a belief system. Nobody wants to really stand up and get scientific about it. So I will basically ask a few questions about the flat Earth theory, and if anybody's here that is a flat earther, we not gonna victimize anyone. We are. It's a discussion, and if the theory is of any credibility, debates at the end of the day are all about growing. Because if you still believe what you believed 15 years ago, today, you either started very well with good information, or you are basically you operate in a system of a cult where you are not comfortable with anything you believe being put on the table and tested and exposed and sieved like a grain of wheat. So why I have a problem with the flat earth theory, number one, is how does one explain base seasons? So we'll start with the shortest season that we have on the planet. Can you guys still hear me? Please wave if you can hear me. Just got a notification that the network is down. Please wave if you can hear me. Wave if you can hear me. Okay. Doesn't look like you guys can hear me. All right. Can you hear me? Can you guys hear me? Wave if you can hear me. Wave if you can hear me. All right. So you guys wave if you can hear me, please. Wave if you can hear me, please. All right. Thank you. That's better. All right. So the basic seasons. Let me not say the basic seasons. The seasons of that the planet goes through, and the most basic one being day and night. So when we look at the regions of the planet right now, in the place where I'm at, Johannesburg, South Africa, it's 3 p.m. and in China the time is 6 hours after, it's basically nighttime. So the first question that I actually asked one of the flat earthers is, how is it, if the earth is flat, what is blocking the sunlight from making the lighting up the whole planet? Yeah, and one of the responses was that the sun is small. Well, we didn't even go into in the direction of asking for evidence of the sun being small or any reference to that claim, you know. Um, and then I gave an example of a globe, a light bulb in a room. A light bulb is very small compared to a room. It fits in your hand, but it lights up the whole room. The only parts of the room it doesn't light up are usually places that are blocked. For example, if you have a fridge and the back of the fridge or something like that, between the fridge and the wall might be dark because of the blocking by the fridge. So that doesn't make sense. And then I think the one guy that I actually who brought me to create the space. Well, we knew he was not going to show up, but he said that the sun travels from the east to the west, and the sun is small. Yeah, the sun is small, so it lights up the earth in segments. All right, so yeah, I mean, obviously we didn't even get to the point of any reference to any scientist that makes that backs up the claim, but logically it doesn't make sense because how do you if it was a matter of if you have a flat surface and you put a light on the other sections, if the light is not enough, they will be dim, they will not be completely dark. So yeah, so that part doesn't really make sense at all. And then it gets really even more complicated. We didn't even get to that part where, because the whole thing of time is more of a latitude. So it's more like left to right or right to left or whatever of the globe. The time moves in terms of the latitude or longitude. Yeah. So now when you look at the seasons in terms of summer, winter, autumn, spring, and whatnot, that depends basically on whether you're in the northern or the western part of the hemisphere, as opposed to time, which is whether you're on the left side or the right side or basically in that direction. So north and southern hemisphere. So you, for example, let me see, a place that has the same time zone, let's say South Africa will share a time zone with a country in, I just forgot what the time zone between South Africa and Egypt. It might be the same or an hour difference there. But there are countries in North Africa that would share a time zone with countries in Southern Africa. Now, and even in Europe and Asia. But, North Africa and Southern Africa. But when you look at the countries that are in the Northern Hemisphere, they are in the opposite season in terms of, if it's summer here, it's winter on the other side. So when we have the winter solstice, like for example now in December, on the 21st or the 22nd of December, we're gonna have the summer solstice here in the south in Southern Africa, and then in Northern Africa we will have the winter solstice on the exact same day, because the seasons are directly opposite. So, but the time zone might be exactly the same. So, if someone speaks of a flat Earth and the sun moving from east to west on top of a flat surface, they need to really explain to us how is it that when the sun moves, let's say the sun is in the middle of the flat Earth and it shines equally at the exact same time on both sides of the hemisphere, how come the other side is winter and the other side is summer? How does one explain that? That's one of the questions. And then we go into other seasons, like the solstices that I've mentioned. We have the winter solstice, the spring equinox, and all that. How does one have all these seasons with a flat Earth and the sun moving from east to west, or whatever the theory may be on how the sun moves? So the question is, how do we have the seasons? And when you wait on the 22nd of December this year, when you go to Karnak Temple in Egypt, the sun will be rising between I think it's the Holy of Holies, right in the center of the temple, and that only happens once a year. So the question is, if the Earth is flat, how do we then explain the phenomenon? Why the 22nd of December? And why do these cycles always have some kind of they come in equal intervals? So if winter comes in June this year, it's going to come in June next year, or in May, or whatever. It's always at the same time, with obviously slight differences in terms of the accuracy of the calendar. Because, for example, your winter solstice and summer solstice, it will have a day variation from year to year, and the whole thing of the leap year, and what so on and so on and so on. So, yeah, so that's the question. And when you look at the Nile, the Happy River that flows from the Great Lakes to Egypt and eventually into the Red Sea, it flows downwards into North Africa. So elevations of the planet. So usually the flat Earth people would argue the whole thing of when they argue that the Earth is flat, they're saying it's not round, as if as if anybody really claimed that the Earth was like round like a ball. I don't think, I've never heard any scientists ever claim that. They usually go by illustrations, and illustrations are there for a reason. I gave one of them used a TikTok video where the guy actually explains that the pilot uses a map that shows the planet on a flat surface, so they can see all the continents on that map. They can see everything, other than when you have that globe one, you have to spin it to see the other side. So that was their argument. And so I explained that that's quite invalid, because if you are an engineer, you know that's I don't want, should I call it ridiculous argument, because, for example, civil engineers, if anybody studied civil engineering, we use cross-sectional views. Or, for example, when you have drawings of a road, what's important is not the top view of the road, which will be what the people that people that use the road when they drive, drivers and all that, they're more interested in what everybody sees on the road. But as an engineer, the cross-sectional view, if you look at the housing plans in terms of architecture, which are also part of the civil engineering course, if anybody studies that, you can see that anybody has seen a house plan. A house plan is flat, so doesn't mean a house is flat. Engineers use drawings differently for various reasons. They'll bring a drawing, they'll tilt the drawing in a certain way, they'll open it up, they'll fold it, they'll cut and look at it from a certain angle. So it's all about the purpose of the drawing. So if pilots use they would have a flat surface as a map, it doesn't mean that that's how the planet looks. Just like the house, no house looks like a house plan. A house plan is flat. If you ever draw a house plan from the top view, it's flat. So that's what architects are interested in when they design a house. It's flat, and then they'll have your elevations, of course, on the side. But that's not exactly how the house looks. So if someone has never seen a house, they might actually think, hey, so the house looks like that, until they actually see the house and they're like, so you guys were lying to us. Where's the top view? Because that's not what you see when you're looking at a house. So they usually argue from very petty angles about drawings, not understanding that engineers manipulate drawings for their use. I mean, even if you've done biology, when there's different drawings of human anatomy, and it comes in different angles, it doesn't mean that if you open up a human being, that's what you're going to see, especially if it's a cross-sectional view. So really that argument of looking at drawings as an argument is quite petty. And because what we really need to explain are all these cycles that the Earth goes through. If the Earth is flat, then what is it that causes the seasons, day and night, summer, winter, spring, and autumn, and also the solstices? And you can even take it further and speak about the Zodiac Cycles. Our ancestors, the Africans, created a zodiac that speaks of the ages, the cycles of the globe or the planet or whatever you want to call it. And they show, for example, currently we are in the age of Pisces. Towards the end, we're moving on to the age of Aquarius, and each age takes approximately 2,100 something years to complete. So for them to actually create a calendar, they had to observe the cycles, and they found that the cycle is actually a cycle because it repeats itself. So seasons are cyclical. So if people tell us that the Earth is a sphere, doesn't mean that it's actually round like a ball. We obviously need to use our common sense. I mean, if anybody, so when they argue from that level, I mean, you could even bring up the issue of elevations. When you look in South Africa, you have Johannesburg. It is at an elevation of about 1,000, almost 1,800 meters above sea level, and Durban around 8 meters, according to the information on the internet. So, how flat is that? And when we say Johannesburg, we're not even talking about the mountain. Johannesburg itself is at a high altitude, hence it has a lower oxygen content, and it's pretty much healthier to live by the coast than in high elevated areas, because you get your lungs get more exposure to oxygen when you live by the coast. And then they brought up the whole issue of sea level, and then I asked them, so I replied by saying that sea level doesn't mean the sea is level. And then I got blocked. That was fun. So yeah, I see a request. So maybe somebody wants to answer a question. Let's have fun. Let's have fun with this. Wait. So we have Nkululeko. Nkululeko requested to speak. Anybody that wants to speak, the floor is open.
Yeah.
Oi.
Yeah, how are you, man?
I'm great, bro. How you doing?
I'm great.
Yeah.
No,
Yeah.
I've been following this whole class thing for a while now. But, you know, and I find a few things very interesting. First of all, you know, they were speaking to pilots about, do you know gyroscope?
Sorry, do I know who? Gero?
A gyroscope?
A gyroscope.
Yeah, I think I understand the word.
Oh, all right. What does it do?
Yeah, it measures your angle. Let me say you are successful. I don't know how to explain this, but it's sort of complicated.
Okay.
So let me just say you're taking a flight from US to London, same hours. You're taking a flight from London to the US, same hours, right?
Yeah.
So they were just asking pilots about do they ever have to adjust their what do you call this?
You've muted yourself. Okay, let me invite you back. Okay. Looks like it's gone. It's back. Okay, invite to speak. Guys, anybody that wants to educate us on why the earth should be flat. You know, some of us love being proven wrong, so we let go of our information egos a long time ago. So yeah, we're not gonna be.
No, sorry. My apologies.
No stress.
Yeah. So you know, I've been following this whole thing for a while now. There's just so many questions. For an example, I think 80% of the earth is water, and we know you can put water on any surface, but if you put water on a ball, it will always flow off, right?
Yeah.
It gets to the bottom, yeah. So it confuses me. When you say the earth is not flat, it's a ball, then how do you explain? So even the temperature of the water, for example, they used to say that when you watch ships, right? Move away from it. Let me say you're at the shore, right?
Yeah.
And then you have to watch the ships move away from you, and then they say, it disappears and all that. But if you use a microscope or binoculars, you can put the ship next to you, meaning that there are just so many things that are wrong. What I'm asking you guys is, do is, at least before we say the earth is not flat, let's just for a moment cancel out what we've been told, and then, I don't know, maybe be open to ideas.
Yeah. No. Yeah, we are definitely open for ideas. That's why we open the space. So the issue of binoculars and whatnot can see a ship. That is quite relative because binoculars can only see as far as they can see. They do not. With binoculars, you cannot. You cannot see. For example, if you're in Johannesburg, you cannot see Pretoria. Well, obviously depending on where you are in Johannesburg, but yeah, the binoculars thing, yeah, I hear that, but because I think I've even seen.
Let's just forget that one.
Okay.
And use this one.
All right.
I think there's a river. I don't know if it's China or US or something like that.
Yeah.
But the river is, I think it's 10 kilometers long.
Yeah.
And then they use this thing. You know those light things, the laser lights.
Oh, please repeat that. That can what?
You know the laser lights.
Oh, the laser lights. Oh, okay. Now I hear you. Yeah.
Yeah. So they were using laser lights to, because they were trying to prove that the Earth is round in a way. But the laser could go 10 kilometers or more. I'm not sure.
Yeah.
And it reached the other point on the other side, meaning the curvature wasn't there. I'm not saying that, but the evidence is just not there that the Earth is round. It just does not make sense.
Okay. Now, you see. Okay, let me address that one. When you
even the sea, let's just take the sea for an example.
the what? The sea.
Yes.
Okay.
Maybe they say gravity, but really can't be. If you put water on the ball, it just falls off. That's it. So I don't see how. I just don't see how anymore. Fine, I used to believe that the end is round too, but after so much research and evidence, this just doesn't make sense.
Okay.
Even the sun.
All right.
If the sun was far away, the rays of the sun, right?
Yeah.
Would always hit straight at you. But I don't know how to explain this.
Okay.
But yeah.
All right. Don't go. I just wanna, because you brought up 2 points. I just want us to take it slow. No rush. So let's start with the water on a ball falling off. So you remember that you are making gravity, right? Let's say the ball itself had gravity. So let's say, hey, how? Remember, gravity is like a magnetic attraction. So if you let's say you had a steel ball, right? A steel ball, and then you put a magnet at the bottom of the ball. The magnet would not fall off.
Yeah, but
you understand what I'm saying?
Can you prove that for me?
Prove what?
That gravity exists.
No, that's a different argument. Remember, if we're gonna now...
It's not.
Hold on.
Because, the argument they use is, they use that argument that, there's gravity holding everything together, but
Okay.
no way.
All right, cool. Check it out. We're not... Okay. If we're gonna argue gravity and the speed of light and we'll talk for 7 days and 7 nights, bro.
Yeah.
So that's why we need to leave it at basically. We can't say we need to prove gravity now, because if you say gravity doesn't exist, you first be what's your reference? You know, but
because that is flat.
well, that's the argument we're having now. That is the Earth flat? So, but what you need to really answer us is, or answer me, is if the Earth is flat, né?
Yeah.
How do you explain? Let's start with the seasons, day and night.
Night, yeah.
Yeah. Why is it that right now it's day where some of us are and it's night where other people are?
Yeah.
And that's the question. Let's start there.
Okay. Yeah. Well, that's a difficult one.
Why?
But the best option, the best answer I can give you is, that they were showing a map. I think it's a very old map. I don't know where it's from. But the Earth is round. And then Antarctica, I'm not sure if it's Antarctica, but the South Pole, right?
Mm-hmm.
Yeah. It has an edge, right? I think it's a wall, but it's an icy wall. It's very tall. I don't know how tall is it.
Mm-hmm.
And then the sun was not as big as they say it is. For an example, the issue of the rays of the sun. Sun rays don't hit straight at you. Because if the sun was that big, you wouldn't be able to see the rays hitting other directions. You would just see rays hitting right straight at you, right? And nothing, meaning nothing would be dark.
Nah.
All sides of the mountain, all sides of the mountain will have brightness, because the sun, will be able to cover both sides. If you get what I'm saying.
Okay. All right.
Because the sun will be just coming straight at you.
Okay.
So,
all right.
In this model I was watching, they showed a round, not necessarily a round, but a circle, right? The Earth is a circle, a flat circle, and then the sun. You know how in the North Pole there's always lights. It could be 8 a.m. Sorry, it could be 8 p.m., 11 p.m. and the sun still, there's still be light, basically.
Mm-hmm. Yeah.
So they were just showing this model where the sun goes around the Earth. It is small. It's not as big as they say it is. Because
who was showing this?
I don't know. Forgot it. But I was watching, a documentary about the USA going to the moon and stuff, and then they were just making a lot of claims, and then they were even showing a video, of them. For an example, let's take this for an example. We have satellites going to Jupiter, to Mars.
Okay, Brad, hold on. Can I just cut you? Hold on.
Yeah.
Hold on. Because you've mentioned too many things. We need to have structure to the discussion. So you bring one point, and then I respond to the point. Because now you've mentioned a lot of things, and now I don't even remember what you started with. Because it started with me asking the question, why the time zones, why the different time zones, why do you have morning in one part and then
because the sun is not as big as they claim it is.
Okay.
The sun is actually inside the dome,
Okay. So can I ask you? Let me ask you a question on what you just said. What is your reference? And then I have another question actually. What is your reference to that? Which scientist has done what project or to actually come up with that conclusion?
Well, the evidence I can point out to is the rays of the sun.
No.
We can't explain how the sun. We can't explain how the sun just,
Yeah.
If the sun is as big as it is, and in fact, there's this guy who did an experiment. I don't know his name, but I think the sun was about 144,000.
Okay.
Hello?
All right.
Yeah, I think he said the sun was 144,000 kilometers away, something like that.
Okay.
But the experiments done.
All right. So okay, so the question that I had asked was if you had any reference to any scientific work that says that the sun is not as big. Okay, you don't have that one. But the question from me personally that you need to answer is, you see, in South Africa right now, the time is 16:15.
Yeah.
In Egypt, the time is 16:15, right?
Yeah.
Exactly the same time. But it's winter in Egypt, it's summer in South Africa.
Yeah.
How do you explain that?
Yeah, well actually, the explanation they gave that was that, the northern hemisphere, right?
Yeah.
And the southern hemisphere.
Yeah.
Yeah.
You can't use hemisphere because sphere has nothing to do with flatness. On a flat Earth, you don't have a hemisphere. But by the way, yeah.
But you get some point.
No. Okay, continue.
And then, so then there's an equator, right?
Okay, all right.
Yeah. So when it's summer on the south, for example, summer, well, I can't use hemisphere anymore, so I don't know which.
Okay, fine, you can use it.
Let me just use hemisphere.
Just say northern part and southern part, yeah.
Yeah. When it's summer is all over the northern part, right?
Okay. Not right now. It's winter. You must. So what I want to know from you, you said that the sun. Hold on. Let me just elaborate on my question. So your argument is the sun is not big enough to illuminate China right now, or the United States, right? So my question is, how is it that the sun can illuminate Egypt and South Africa exactly on the same point, same time zone? But that side is winter and this side is summer. How come? I want to know that.
Because the sun is smaller than we say it is, right? For an example, when it's summer, right? The sun moves south. Okay.
In what? Okay. All right. So before you continue, just explain the pattern of the sun from a flat Earth perspective, because the way we understand it, the sun does not move. The sun is still relatively, and the Earth is the one that moves, that revolves around the sun, and has its own. It revolves around the sun and rotates around its own axis. So before you go to how just explain the basic movement of the sun. How does it move circular? Does it move in a straight line? How does the sun move around the Earth?
Well, my understanding was on a flat Earth theory, that the Earth is flat and still.
Yeah.
And the sun is moving, right?
Okay.
So when it's summer on the north, the sun is
Bruh, you are robbing. Yeah, you are robbing me, bruh.
Actually, I don't know how to put this in English.
Okay, hold on. Before you go to where the sun moves south and north, before you get to that, just explain the pattern of the sun on a flat Earth. Don't leaving out. How does it move? Does it move in a zigzag? Does it move in a straight line? Does it move in a circular form? Give us the pattern. We have a flat Earth, right? How does it move from in a straight line? How does it move? That's what I want to know. The basic before you explain how it ends up in the south and the north. And yeah.
Okay. It goes. I think it moves in a circular thing.
Or it moves in a circular.
Direction. Yeah, it can't move in a straight line.
Okay. So if it,
yeah. For example, let me just say you take a plate, right? Then let me just say you take a plate.
Yeah.
And then you take maybe a small light, a cloth or anything like that, and then you move it around the plate. I think it moves like that. That's the model they showed there.
Okay, so you're saying if I take a torch and I move it around the plate, that's how it moves.
Yes.
But if I do that, the whole plate will be illuminated. I won't have that the pattern.
It depends on the amount.
It depends on
no, but it depends on the amount of light. It depends on the amount of light.
All right.
And how close it is to the surface, right?
Okay, cool.
So if you take the light far away from the surface, it might illuminate the whole plate. But
okay.
If it's close to the surface, it will not.
Okay. So you're saying it moves circular on a plate.
Yes.
Now, if it's moving circular, if you were to take a torch and move it circular, right? And you're saying it doesn't illuminate, it will illuminate the edges, right?
Yes.
The center will be dark. When does it illuminate the center then?
No, but it depends on how far it is from the plate, right? It can illuminate the center. For example, as I was explaining before, that the northern pole, I think it's Norway. In Norway, even at 11 p.m., there's light, right?
Yeah.
But if the earth was in summer.
Okay.
But when the sun moves south, Norway becomes dark too.
Yeah, when it moves south.
Yeah.
But Norway, okay, if Norway is in the north, the earth is flat
yes.
and it's moving circular.
Yes.
So while it's illuminating Zimbabwe, you have light in Norway. How?
Okay. Let me just explain it like this. The way I saw it there was, it's summer here, right?
Yeah.
It's summer here. So the sun rises early and then sets late, right?
Okay.
Yeah. That means the sun has moved down to the south. When I say moved down to the south, I don't know how to explain this to you.
All right.
Let's
Okay.
take the plate model that we're using.
Okay.
And then put an equator there, right? A line, you know. Maybe I don't know. In the middle of the plate. Let's just put a line there, right?
Yeah.
So
yeah, okay. You can cut.
It goes according to physics.
All right.
Hello?
Just okay. I'll bring you back. Just gather your thoughts a bit. Let me give Matumza a chance to come in.
Okay, that's fine.
Yeah, just gather your thoughts. I still need you to explain why right now the time in Egypt is 1623, the time in South Africa is 1623, but in Egypt it's winter and here it's summer. I still need to understand that from a flat earth perspective. All right, Matumza, you may speak.
Sure, man. I just wanted to follow up on Nkulewa's theory. I wanted to understand whether on a flat plate,
Yes.
does the torch revolve around the plate circumference, or does it revolve perpendicular to the plate circumference? Because
Yeah, that's a good question.
Does it revolve around the plate circumference, like,
Yeah.
or does it revolve perpendicular, meaning the night will be when the torch is on the bottom of the plate, and then the day will be when the torch is on the top. And now, okay, I just want to understand that.
Yeah. I think that's a good, because the challenge with Nkululoge, what you are saying is, if the sun moves circular, or it moves in, you said circular, right? Yeah, you said circular around the flat Earth. It does not answer two things. It does not answer how, because remember, every part of the planet has the peak, the height of the sun's rays, like 12 when the sun is at noon, when it's at its brightest or hottest and whatnot. So it does. So you haven't explained how the sun would be illuminating the central section of the flat Earth, and also it does not answer. So when the sun is moving in the north in Egypt, why is it winter there? The sun is basically the time zone. Yeah, it's basically the same.
Yeah.
So why is it winter there?
Let me answer my terms of first.
Okay.
My understanding is it moves along the circumference. My understanding is that it does not go under the plate. No.
Okay. Hold on a second. So the flat Earth, sorry to disturb you. The flat Earth has a circumference.
You are really confusing me now. Because if you have got a plate, right?
Yes.
Either you're going to move around the plate in a way that you go across the plate and below the plate, or you're going to go around the circumference of the plate, meaning there is no night. Because it's always on the top, it's just circulating around the plate.
Yeah, exactly that. That's exactly what I'm saying. It's always on top of the plate. But
so why are we having night?
Listen. But it does not illuminate the plate all at the same time. It's not the light is not as far away.
Chief, right now, we wake up. It's morning. The sun rises.
Yes.
There's no sun. Evening means no sun. Now, how then do you explain to me that the evening has got no sun, but the torch is still above the plate?
Well, as I was explaining to as I was explaining to Musoni, the sun is always on top of the plate, right? But the sun is not as high as it doesn't illuminate the plate all at the same time. For example, if I take a torch and bring it closer to the wall and bring it far away from the wall, it is possible that I can illuminate one side of an entire wall. But if I bring it closer to the wall, it is possible that I can illuminate small sections of the wall. Do you understand what I'm saying?
I think you need to take a plate and take a torch, because otherwise you are telling me that the sun is waving in and away from the plate, in and away from the plate. That's what you are saying. Now it's waving on its own axis, because you are away, you are near, you are away, you are near, but you are always on the top. So does it have a line of rotation? If it does, because what you have to understand is that there's something called a radius, right?
Yeah.
The radius will be from the center of the plate to the torch, okay?
Yeah.
Either the torch
Well, from the center to the end point of the plate, that's a radius line, right?
No. We are talking about the sun relative to the plate. We are not talking about the sun relative to the edge of the plate. We're saying, okay, this is daytime. You're either saying to me that my daytime means from the center of the plate to the center of the globe. As you're saying, it's circulating around the plate. It doesn't move below the plate or the other ways around.
No. It's always on top of the plate, yes.
Always on top of the plate. Then why are we... unless otherwise I don't understand. Maybe you can walk away from the head.
Let me put it like this. Not all torches. Let me just say we have a plate with a diameter of say 60 centimeters, right?
Okay.
Yeah, and then we have a torch with a diameter of maybe say 10 centimeters.
Okay.
Yeah, to get my point.
Okay, so the question. So the question I have for you.
Let me just answer my terms of that.
Okay. All right. Cool.
The way I understand it.
All right.
And then on a 60 centimeter plate, you take the 10 centimeter torch, you bring it closer to the plate. Let me just say you put it on the plate, maybe.
All right.
When you put it down, it will only illuminate a small portion of the plate.
Okay.
If you lift it up a little, it will not illuminate the entire plate, right? It will illuminate some parts of the plate, but not all of it.
All right. So the question. So my question is, when the sun is at this point on the plate, let's say in the northern part or whatever of the plate, how much of the plate does it illuminate when it's at a certain point?
Let me just say you've taken the torch.
Yes, I want to know how much when it's on that point on the plate. How much of the plate does it illuminate since it moves around in circles? How much does it illuminate? Because we have a 60 centimeter diameter. Does it illuminate 30 centimeters, 10 centimeters of the plate? How much of the plate does it illuminate in this scenario?
Let me just say, I think, let me just say it illuminates 50% of the plate.
Or 50% of the plate.
Yes.
So,
for example, if you put it down, I think it may illuminate about 10% of the plate, right? But if you lift it up a little, it might illuminate maybe 30%, a little more, 50%, a little more, 100%. Do you get my point?
Okay. So, in other words,
100% about at daytime. Because this is saying 100%. It means at 100% we are all at daytime.
Yes. No, but right now I'm just making an example, right? Well, the sun is high enough to illuminate 50% of the plate. That's what I'm trying to explain.
Okay.
So you are confusing me even further.
All right. Okay. Let me just interject quickly. If your plate illuminates 50% of the plate, as you say, it still does not address why the sun right now, if it would illuminate 50%, if the sun is in the north, it would only illuminate the northern hemisphere. we'll use hemisphere since you say that the flat Earth has a circumference, and a circumference means we have a circle or a circular sphere. In other words, it doesn't have to be an exact ball. So if the sun illuminates, it means the time zone would not, the northern part would all be illuminated. It would not be like we have right now. Egypt, like I said, it's 1634. Johannesburg is 1634, exact same time. So if we're to use that scenario, where is the sun? Because we are in the most southernmost part of the continent, and Egypt is in the northernmost part, and they are above the equator. So where is the sun? Is the sun in the south where it's shining on us? And how does the light get to them? Because if you use the scenario of the ball on a plate, if it illuminates half of the plate, if it's on the south, it would illuminate the whole half of the southern part of the plate. That's the challenge.
For an example, 50% is an example.
No. The example is accepted. We've accepted the example, so you need to make sense of that example. You don't run away from it. Yeah, that example sticks. So
let me just say, maybe the torch is lifted up in such a way that it illuminates maybe 30% of the plate. Just for an example, because I don't have the exact figures yet.
No, it doesn't matter. No, let's stick to the 50%. Because it's also fine. We accepted. We're talking about a plate now, and the debate is about the Earth. We're using the plate because we are trying to, anything that exists in the universe or in nature can be simulated within. Hence, you have scientific experiments to see if a theory would be feasible or not. You first do a laboratory experiment by simulating that specific theory. So, and you've given us a plate, a torch that illuminates 50% of the plate. So all I'm saying is, with that scenario, if the torch is in the northern part or the southern part, it would illuminate the southern part. If it's in the eastern part, it will illuminate the eastern part and the northern part. But that's not the reality as we speak right now. The sun, the sun illuminates, hold on. The sun illuminates Egypt and South Africa exactly the same way. But the other is in the north, the other is in the south. You cannot simulate that with a torch on a flat surface. It's impossible.
Okay.
That's the challenge.
Well, first of all, let's take this example.
Okay.
Well, my guy, is my phone, talked about the radius of the Earth, right?
Okay.
Which means that's the line that goes from the center of the plate to one end of the plate, right? Right.
Yes, we